Hey everybody, hope you are doing well. I just wanted to make a more detailed video if you want a little bit more support with the reading. I know that the article isn't very long, but there's definitely some words that can be tricky. And so this video is going to be a little bit more detailed to help you out with that. Yeah, feel free to pause as you go. So if I'm breaking it down and let's say you hear me say the claim or you're like, ooh, I know that that's the author's claim, you can pause the video, type in the claim, and then, go with that for each step. So let's get started. So the title is Mitochondria and Aging. Remember, the mitochondria is that little organelle, that little part of the cell that's doing cellular respiration. And remember, the purpose of cellular respiration is to take glucose from our food that we eat, take oxygen, break that glucose down, and make ATP, which is cellular energy, right? Which is what our cells use to do work. So I'm going to start reading the first paragraph. So Aristotle believed that we possess a finite amount of some vital substance, whatever that means. When the substance is consumed or used up, we die. The idea was based on the principle that if you use something long enough, it will eventually wear out. Some philosophers even argued that each person had a finite, predetermined number of breaths or heartbeats, and that once they were used, you would die. Biologists have always been curious about what causes aging and death, and solving that riddle may be the key to longer lifespans and better quality of life. Scientists proposed a new hypothesis based on this old idea of a vital substance that energy consumption limits longevity. In other words, an organism's metabolic rate determines its lifespan. So that first paragraph was really just giving you a little bit of ideas of what people throughout history have thought about aging and about death. Again, some people just thinking that every person has an exact number of breaths or heartbeats, which is kind of crazy. Um, and so, it does say this vital substance. It could potentially be that energy consumption or using energy limits longevity, which means that those things are not lasting as long, right? So in other words, an organism's metabolic rate determines its lifespan. And so that's what it's looking at when we say metabolic rate, is how quickly things are broken down. All right, now the second paragraph. As we age, the mitochondria becomes larger and less numerous, meaning there aren't as many, and sometimes develop abnormalities with their structure. So that means they're not the right shape that they should be, right? Experiments performed on mice show that increased levels of mitochondrial mutations are related to a variety of age-related changes, such as osteoporosis, hair loss, and weight reduction. So that sentence is really just saying that scientists have done studies on mice, and what they've noticed is if a mitochondria has more mutations or it's more abnormal, then they're starting to see changes that are usually like associated with like age, right? Or aging or getting older. And osteoporosis is one of them, where the tendency is that older people tend to have more frail bones, like their bones break more easily, or losing hair, or losing weight, which is why sometimes we see that in really, really older people. The mitochondrial theory of aging says that the accumulation of damage to the DNA of a mitochondria leads to aging in humans and animals. And so what this says is basically that um, this is saying that people who agree with this mitochondrial theory of aging are saying that as the damage to the mitochondria increase, right, like from the DNA mutations, as more and more DNA mutations happen, it's leading to more and more aging in humans because those mitochondria aren't um, what they should be, right? So think about what we talked about with DNA and mutations, and how um, you know, a cell that's mutating can just continue to mutate, and it's like the mutations get kind of more and more intense. Think of something like a game of telephone. If you start with a message, by the time you get to the middle, maybe some of the message is there, but by the time you get to the end, none of the message is there. That's kind of what this paragraph is talking about. All right, I'm on the third paragraph now. Mitochondria are unique in that they are the only organelle in an animal cell that possess their own DNA. meaning they have their own specific DNA for themselves to go about making themselves. It's referred to as mtDNA, which is separate from the DNA in the cell's nucleus. So you know that DNA that makes you that we talked about before, we were really looking that that DNA is in a nucleus. Well, now this is saying that even those little mitochondria, they actually have their own set of instructions. And so they do their own thing. They have their own set of DNA. When a cell divides, mitosis, we learned that, the mitochondria divide independently, meaning they divide on their own. And new mitochondria are passed to the new cells, right? Because again, that mitochondria has its own DNA. So it does its own little division and it gives those mitochondria there. New daughter cells created through mitosis are identical to the original cell. Remember, because we said that they have to have identical copies of DNA, but may contain mitochondria that have new mutations, because remember, those mitochondria have their own DNA. So even though my nucleus's DNA might be identical, maybe the DNA that's in my mitochondria isn't identical to what it should have been. Every new cell division has the possibility or chance of resulting in mutations. We know that within the cell's nucleus and within the mtDNA, right? And we know that that can happen, right? And that's actually what we're going to look at in our next unit. So that paragraph is really just reminding you that our cells divide because that's how we grow and develop, but it's also giving you that information saying that our mitochondria have their own specific DNA. And so that's really what scientists are looking at potentially with aging and death. Right? How are mitochondria and metabolic rate related? Metabolic rate refers to the amount of energy that is used by an organism to maintain life processes. So it's basically how much energy, how much ATP do you need to have to maintain your life processes, right? That's really what it's looking at. On a cellular level, the mitochondria use oxygen to convert food or glucose to an energy storing molecule called adenosine triphosphate, or just ATP. We know that. This process is called cellular respiration. We know that too. The ATP produced in this reaction is then used by the cell to maintain homeostasis and ensure the body that the cell and body function normally. So remember, when we talk about homeostasis, we talked about it a long time ago. So I'm going to give you a little refresher. Homeostasis is that idea that we're maintaining, our body is maintaining balance of internal conditions, right? The example that I gave at that time was, if you're feeling really hot, what does your body do as a reaction? You should be sweating, right? Because the sweat should be cooling your body temperature down to get it back to normal. If you're feeling really cold, what does your body do? You start to shiver, right? Because the shivering warms up those muscles with that friction and hopefully gets you back up at that point. So that's what we talked about before when we talked about homeostasis. So this paragraph is really talking about metabolic rate. When you're thinking about it, just means how much energy you're using. That's the fancy way of saying that. Or how much ATP you need, right? How much cellular respiration. So, you know, if we're doing a lot of, if we have a high metabolic rate, that means we're doing a lot of cellular respiration. That probably means that we're making a lot of ATP because we need it. But that also means that our mitochondria are getting used more because we're going through more cellular respiration, right? So I'm hoping that this video, I know it was a little bit longer than the other ones, but I'm hoping that it breaks down the reading a little bit more for you. I don't want any of these words to scare you. You are smart, you've got this, try your best. As always, private message me if you need any other assistance, but I'm hoping that this video was helpful for you.